Section 2, Video 8. Let's take a look at some more interesting questions here. Here we have, again, a root in the denominator, and I'm going to take the same line of thinking here, and I'm going to rewrite that root on top with the root on the bottom, and put them in the same root and see if we can simplify. Well, I do know that I can take an x away out of the top and the bottom. I can take two y's away from the bottom and top, and we end up with 3y squared over 5x. Now if I take that back to our original question, we now have 3y squared in its own root again. On the bottom we have 2 root 5x. We've also said we should try and simplify the roots if we can. Here we have y squared. Now the square root of y squared can be done. That can come out, and that gives us y root 3. And on the bottom, root 5x cannot be taken any further, so that simplifies it a little bit further. Again, we want to do as much as we can before we try to rationalize, because we want to make that process as simple as possible. And again, to rationalize, we are to multiply top and bottom by what we consider the problem. And the problem is root 5x. That is not acceptable to have in the denominator. So if you multiply top and bottom by root 5x, on the top we get y root 15x over, heck of a time with that one, sorry about that, 2 root 25x squared. Now that's important because on the top we have a root, which is okay. On the bottom though, root of 25 is 5, root of x squared is x. We take that times what's already out in front, and now we have 10x. So again, we cannot simplify things that are in roots and out of roots. Even though we have a 15x and a 10x, they cannot be mixed up. They cannot work together. They stay separate. So this is as far as it gets. Now on a much lighter note, here we have a problem that's a little bit simpler, sort of. We have to remember that with this plus symbol, these are locked together. So we can't just say, oh, I have root 3's I can cancel. Can't do that. So this one actually is as simplified as it gets with respect to the roots, but we do still have to rationalize. And I'm going to rationalize top by taking top and bottom times root 3, because that is the problem. We can't have a root in the bottom. What's different about this question is the bottom becomes 5 root 9, which turns into 3, so we have 15 in the bottom. Now on top, it is a distribution question, so it takes us back to some previous older questions. So 3 root 5 times root 3 is 3 root 15. Then root 3 times root 3 is root 9. So we have 3 root 15. Root of 9 is 3. Now, this is what you have. The question is it simplified? And if you notice, all three terms have something in common. Again, things inside the roots work together, things outside the roots work together. We have a 3, and a 15. So I can take a 3 away from everything and get root 15 plus 1 divided by 5. So I take away a 3, I divide each piece by 3, and we end up with that answer. So a very good example of a different kind of simplifying question. So we have to pay close attention to if the numerator has a binomial in it or not. And this ends Section 2, Video 8.